what's it actually going to cost for me to get a consumer bot?
It's more in the size, like the cost range of a car. It's not a luxury car, it's a car.
AI has gotten much, much better. We've got better compute. What's the big shift that's allowed robotics to really boom now?
It's actually not quite true that this has only to do with AI. 15 years ago, we weren't able to build the biodynamics that makes this into a system that can be actually safe.
Can I, hypothetically, don your VR headset and start teaching it karate? Would I be able to sell my karate skills for $20 a month? Ladies and gentlemen, today I'm talking to Bernt from 1X Robotics. You've probably seen their videos all over Twitter. 1X Robotics has been doing fascinating work, and I've been learning robotics myself. There's a hardware revolution just around the corner. I'm still a noob, I'm still learning. The coolest part about what we do here is I can ask the smartest people in the world to sit down across me and I can ask them questions. I can ask them, how do I get into this? Where is the future headed? What are the business opportunities here? I can do all of that today. That's the greatest advantage of creating content. I hope this is a very enlightening conversation. It starts out a little bit technical, but over time it gets pretty interesting, even if you're a layman, if you're an investor, if you're a financial investor, if you're not a financial investor, you just want to know where the world is headed. If you're an entrepreneur, this video is super enlightening for you. There are opportunities that have never been seen before. If you watch this video, you will walk away saying, holy shit, I have 10,000 ideas. So make sure you stay tuned and I hope you like it. Ladies and gentlemen, welcome to another episode of, I don't know what we call this anymore, but I was just thinking when Dar reached out to me, right? So Dar reached out to me on Twitter and he said, hey, do you want to chat with Bernt? And I said, that would be lovely. I just realized I've been tinkering around with robotics for a bit now, right? I'm a complete noob. I'm still playing at the software layer and not really manufacturing anything, like we're too small for that. But I thought it was really cool that any question I have about the future of any industry, about the future of things like robotics, about how do you actually build everything up from just tinkering around, I can just ask the best in the world. And today I have Bernt with me who's, I think he needs no introduction because he's sort of like, I keep seeing a video by 1X every week on my Twitter. You guys are building really fascinating robots. And, it's just, I've dreamed about robots. I've dreamt of robots ever since I was a young kid, like being, in cahoots with a bot, it walking around my house, it cooking with me. I know that's super nerdy, but I'm sure everyone's had that dream. I'm sure you've had that dream as well. So thank you so much for being here.
No, it's a pleasure to be here. I look forward to the conversation.
Awesome. So I'm just going to dive straight in. This is just me as a curious person trying to dabble with robotics, trying to learn as much. Maybe we'll pull out some career insights. Maybe we'll pull out some where's the future headed insights. We'll also find out how many years away robotics actually is for us, right? For humanity as a whole. And also for India, right? Like I think we do have a sizable audience from India. So everyone here is curious about, are they actually going to make it to the country? Because it feels like some of these revolutions, they take forever and then snap and they're there, right? So thank you so much. I'm going to dive straight into the questions. So my first question for you is, how did you start 1X? This is going to be the slightly boring generic question before we dive into the meat, but how do you start this? How does one start a robotics company?
It's actually a very good question. So I feel like for some part of me started this like when I was 11 years old, because I decided very specifically what I wanted to do. Mainly inspired by Honda Asimov, which like it's still like the most amazing like feat of engineering. I recommend people to go to like YouTube and watch the Honda Asimov P6. It's 25 years old now. And he was running over stage, walking up and down stairs. Amazing system. Never ended up going to Japan, but I worked in a lot of different industries for a while, learning everything from how to build the hardware all the way up to the software. And then I found an investor who was willing to put a lot of money into this and see where we can get it. It's really hard to bootstrap robotics, right? It's getting easier these days, luckily, with like 3D printers and more off-the-shelf hobby servos and things like this. But back in the day, it's 9 years ago now, so it required a lot of capital up front, and that's always challenging. But super thankful that I got to go on this journey and see what we could do with it, and hopefully we've put it to good use and we've built some pretty great robots. So we'll see where it takes us.
Do you remember the first experiment you ran with robots? Like, what was it? Did you write some robot operating system code? What was it? And when was it?
Well, to me, like robots is everything that moves, right? So, I started very early. I'm the kind of kid who like picked apart everything and put it together to build something else, to my mom's frustration. So I guess my first robot might have been the food processor she had that I harvested the motors for and built the tool. It didn't make me very popular, but I learned a lot. Yeah, I mean, I started programming back in probably 12, 13, something like that, making game mods for Quake back in the day, an arena shooter.
Yeah, I think everyone starts there. Like, so many people in robotics just started with game dev, right? Like it's very similar.
My second passion has always been 3D and game dev. But anyway, I quickly realized that the thing that gets me off is when I press run and something actually moves, right? It needs to move in the real world. So that kind of set me on that path.
Yeah, interesting. So I have a question, right? Now I'm going to dive straight into the questions. Okay, let's say I was building a robotics company tomorrow, right? And when you started this company, what was the core team like? I'm sure today you have a lot more employees, but let's say I was running a robotics company with very little capital raised. What are the 5-10 core roles, key roles you would fill? So I just want to do a play-by-play going from where 1X started to where it is today. What's the play-by-play? Who do you hire first?
I think you hire someone who's really, really freaking good at prototyping. Because this is real world experiments is the only thing that matters. If robotics was a simulation problem, it would have been solved long ago. It's amazing what we can do with robots and simulators. Now, sadly, simulators are so far away from reality that it's hard to even grasp, right? I think my simplest example of this is when we do a lot of mechanical engineering here, you can do something as simple as just you have a few bolts in a bolt circle and you want to simulate how this will behave for a very small time window of a few milliseconds while under load. And this still takes you a day or two to simulate on a pretty big, beefy computer. And even then, you still need to test your bolt circle in real world afterwards. So the real-time simulators that we run today, they're incredibly inaccurate. They're very useful, but they're very inaccurate. So you need to do real-world experiments, and the speed of iteration at which you can do real-world experimentation is really going to define the capital you need to get the hardware right.
Interesting. So the first role would be, let's say, somebody who can build real world prototypes. Do you also have somebody else in the team running simulations or putting this into simulation software or sort of guiding real world movement?
Sure. It depends on who you are, right? As a founder. So for me as a technical founder, we could design the hardware and write the software. It was more on the prototyping side. But I think it's super important to just leverage yourself, right? Use modern tools. That's to me what software is a tool that allows you to create more tools. That's why as software engineers, I still kind of look at myself as a software engineer, but that's one of our big advantages, right? We look at tools for doing something and we're this is shit. And we're I'll build something better.
Have you done a lot of that?
Yeah, we've built so much tooling. One of the first things I did actually when I started the company was sat down and just looked at, okay, what's the problems in the space, right? So again, back to the Honda Asimov, why isn't there robots all around us just helping us live our life in a better way? Well, why did it fail, right? And it has a lot to do with, it's a bit complicated, but it has a lot to do with the dynamics of nature and how when you build robots that have very high gear ratios or mechanical advantages, which is what we generally do, then they're very accurate, but they're very stiff and they're very high energy. And this makes it incredibly hard to operate in a world that is unstructured, like we say in robotics, which basically just means a world where you don't know where things are. So if you if I use my arm just making to show, right? If I do this, which generally a cobot wouldn't do because it would be dangerous. But if I do this, it's very simple as a human to move this fast. Yeah. Now, interestingly enough, inside my body, actually nothing moves faster than my arm. While in a robot, you would have a gear in here and a motor. And if that gear has a 100-to-1 ratio, which is quite common, then this would rotate 100 times faster than the arm. Now, your kinetic energy is the velocity squared. So that's actually 10,000 times the amount of energy. So you're now inducing an enormous amount of energy into the system, and then you need to stop. So if there was a cup here that I'm picking up,
your error margin is lower.
Or it's not even error margin. It's actually just the energy in the system. So when I'm picking up this cup as a human, I'm actually not fast enough to know that I'm touching it when I stop my hand. I'm actually colliding with it. everything you do as a human throughout everyday life is basically colliding. Your feet are colliding when you're walking, your hands are colliding when you're manipulating. And then the passive dynamics of your body is just very low energy. Even though you're moving fast, not that much energy in the system that needs to dissipate on contact. And you're just adaptable and compliant and over-damped. So everything's just stable. I mean, Bruce Lee has the best quote on this, right? So, flow like water, don't be stiff. Like that's the secret to martial arts. Canonical example here for robots is opening a door. And then you see the stiff robot is gonna like win versus the door. But the door will win. Like the door will go where the hinges dictate, not where the robot wants the door to go. That's gonna end really badly for either the door or the robot. Humans don't work like that. We're just soft, compliant, adaptable. We kind of flow with it. So we don't say to the world like, this is how it's going to be. We say like, this is how the world is, and we're gonna kind of adjust to that.
And this tracks back to you saying that in simulation, anything goes, but in the real world, bots will need to be tamed.
Yeah, this is just basically you don't even have the actuator dynamics in the simulator typically, right? So you never see this. But back to your question. So basically what this means is you got to get rid of the gear ratio. You got to get rid of the gears and the gear ratio. And that doesn't work because we're very good at making motors that are high power. But to get power, they need a lot of speed. They need a lot of RPM. So really, how do we make motors that are kind of more like muscle? They can produce a lot of force or a lot of torque, but they don't need a lot of speed. So that's really where I started. So spent the first half a year designing motors that just would enable us to use these tendons. We have tendon drives in our robots today. So we're pulling on tendons to move, kind of like humans with muscle, instead of having the classical gear solutions. And that was an interesting project because actually that ended up being writing a lot of tools. How do you use modern AI connected to more old-fashioned simulators that can simulate electrodynamics and search for the optimal solutions in this space of electromagnetism, right? So that was kind of like where I started. And based on that, we built some pretty great robotic arms in the beginning, just for the lab to show to investors. And then after we then raised external capital, started scaling the team and building the full humanoid. That ended up being Eve, which is the one we started shipping. It's coming up on 3 years ago now, into more of the enterprise. And then now, of course, everything is about Neo, which is the new biped targeted towards consumer and domestic.
Yeah. So what's the team like today? Like assuming you have, how many employees do you have today?
We're about 125.
Okay. And what's that broken down to? What's the titles of the teams?
So it is everything really. So we have manufacturing engineering that develops basically develops the machines that builds the machine. So we have a lot of IP in everything from how to make super accurate, precise formed copper coils and how to assemble motors based on this, magnet arrays, all these things, ropes for like the tendons, building all the machines that can build this in high volume, right, and at a low cost. And then we have the design team, actually the mechanical engineers, the electrical engineers that build the robot itself. And we have what we call the foundational software team. So they build the firmware, the OS, and the deployment and fleet management tools. And then, of course, it's the AI team. We have a controls team, which we don't generally do classical robotics controls, but it's incredibly useful to have people who deeply understand robotics and just figure out what's wrong. So generally, it's like system identification, figuring out why things aren't working. Calibration is a big one. And just like building tools to automate all these procedures as you move into volume manufacturing. And then, of course, it's all of the normal operations of a company. Like you have HR, you have admin, you have finance, you have sales. But the company itself is very flat and very mission oriented. We have this mandate of like there's no like pure middle management or no product. What's it called? Like there's no product managers or project managers in the company. We have a pretty strict rule on even the VP level that leads pretty big teams at this point. they need to be 20% individual contributions, 80% management, and that the team leads need to be 50-50. And we track that pretty aggressively to ensure like people know what they're leading and really understand the product. And that goes all the way up through the organization. And then as few layers as possible, a lot of creative freedom, and just make sure everyone knows what the mission is, right? We want to create an abundance of labor through intelligent androids. So we're very blessed in that, like, we know exactly what we're doing. We know what we're building. We know what we need to do. And that means you can run a pretty lean organization on the management side and build a culture where people really feel like, I came here to learn and I did my best job, like the greatest work in my career, because I got to just do my job and I knew what I needed to do and no one got in my way, and just clear the path.
Interesting. Why hasn't this been possible so far? Because I assume on the manufacturing end, this was possible maybe, half a decade or maybe a decade ago. On the software end, obviously, we have, AI has gotten much, much better. We've got better compute. We've got better GPUs. For the audience, that's a graphic card. What's the big shift that's allowed robotics to really boom now? Because I'm seeing all of you at the same time, right? Like the Optimus is now coming out. You guys are coming out.
That's the thing, right? So like once the timing is right, a lot of competitors pop up, which is good, right? That's how the speed suddenly accelerates, because now you can't slow roll. It's like you gotta go all in. You gotta win. And I think it's actually not quite true that this has only to do with AI. I'd say it's like 50-50. 15 years ago, we weren't able to build the biodynamics that makes this into a system that can be actually safe, that can be cost efficient. You could build more of like typical stiff industry, like factory automation type robots. And that's actually what most humanoids are today too, that you see. They're the same kind of systems. And then in well-staged videos in the lab, you can get this to look very impressive, kind of like on the Asimo. But it's very, very hard to get this to work in the real world. And it's basically borderline impossible to make it safe and to make it affordable, which in the end is what's going to allow you to deploy at scale. So that has a lot to do with what's been happening in on the motor side. And what we're really trying to do here is to track an exponential, same as, call it Moore's law for robotics, right? So the first motor that I designed had about like 2.5, 3 times the world record in torque to weight. And the one that's in Neo actually has like a bit more than 2 times that again. And then what we're working on in the lab for future versions has about 2 times that again. So like trying to track this exponential force density of actuators. Because every time you see this increase in density in force for actuators, you see like a leap in capability of robotics and how dynamically and naturally and safely and compliantly systems move and what that can do. And this is incredibly important if you want to learn anything, because you need to be able to explore the world without your system breaking. So think about a robot just like trying to open a door, right? So it's hammering its hand into the handle or the door or whatever, like repeatedly for 8 hours trying to figure out how to open the door. And if you need to repair in the hand or the robot or the door all the time, this is going to be very, very hard. And the other part of it is actually the manufacturability. Like you need to make sure that you build your system in a manner where you don't need any special alloys that are very expensive. You don't need very tight manufacturing tolerances. You really want to just get down to first principles of like, how can you build a very loosely relaxed system requirement-wise with as cheap materials as possible and get the weight down as much as possible. And then you can build something that's very, very affordable. And in the end, this kind of is often underestimated how important this is. I like to say, like, if you think about the EV space now, there are so many companies there that they're building great cars, like startup companies building great cars, but it's not cost effective, right? They're losing hundreds of thousands of dollars per car they sell. Clearly that is not going to work. And robotics is no different. Like if you have a product costs 20% more than your customer and then your competitor, you might be able to find a niche. If you have a product that costs 5 times your competitor, you're out of business. That doesn't work. So it is really not necessarily a race to the bottom, but you have to put manufacturing first as part of like the DNA of your company from day one.
It has to be scalable.
Yeah, and the strategic decision you decide on your hardware, this is why I mean this is important from like the hardware, not just the AI, is what defines this. Because if you go for the classical route of like harmonic high-speed reducers that are used in industrial robotics, for example, then that system, like the limit cost of that system is maybe, I don't know, maybe you can get it below $100,000 for a humanoid if you do a very good job and have extremely high volume. But it's never going to be affordable.
Consumer. It's never going to be.
Yeah, it's never going to go into consumer. It has all these other problems with like the dynamics and everything. But even if you ignore that, it's just, you're not going to get to that cost level. And you can't just go back and say like, oh, now we're going to make it cheaper. Like then you're like, oh, we have to restart everything done and we have to just build a completely different type of robot. So I think that really has to be part of your DNA, same as safety. And clearly, the AI has gone through an enormous amount of progress the last few years, right? And when I started the company 9 years ago, that was also kind of on purpose. Like, okay, I think we have a shot on trying to build like the biodynamics of the system to get it right. And that's going to take quite a lot of time, because this is like hardcore deep tech R&D and then manufacturing. I want to position so that once the AI space is able to solve some of the key problems here, we can actually leverage that.
Before we dive back into our main conversation about AGI and robots, I want to talk about something that's been on my mind lately: the future of sustainable AI. You know, it's crazy how AI is evolving, right? These AI models are getting bigger and more complex. The other day, I was just scrolling through Twitter and came across this image of Elon building a massive data center. Look at the scale. It's just insane. I've been keeping an eye on some companies taking a safer, more sustainable approach to AI. And Intel, they're right at the forefront of this. Intel is taking a unique approach towards AI by focusing on bringing AI capabilities directly to consumers. They've developed what they call AI PCs, which are powered by their latest Intel Core Ultra processors. These processors enable you to run AI apps locally right on your device, potentially lowering overall power consumption, because now the computing power is distributed across many devices instead of centralized in energy-hungry data centers. Most importantly, these new AI workloads require systems with new silicon to run more efficiently. These include a new piece of silicon architecture called the Neural Processing Unit. It's interesting how Intel is taking this unique approach towards AI. They're focusing on the end consumer first. This could potentially lead to a more distributed model of AI computing, reducing the need for massive centralized data centers. So, what do you think? Is local AI processing the future of sustainable computing? Let me know in the comments below. And if you want to dive deeper into Intel's AI-focused chips, I've dropped some links in the description. Now back to the conversation.
So, I mean, and this is a bit surprising to me, right? Because back in 2015, things were already starting to happen. It wasn't really transformers yet at that time, but it was language models. And the AI space was progressing pretty fast, also on vision models. And it actually took a bit longer than I thought it would before this really kind of like broke through. And when I met Sam back in, I think it was that summer 2022, when we started talking about doing something together, that's really like the first time where like we realized that this is the time to go all in on this. Like this is going to work. And that was quite interesting because that really shaped the company. And I think it's one of those like very important times in like a company's history where you make like a pivotal decision on technology and you have to just be very like crystal clear on all in. Because if you try to hedge your bets, there's like 100% chance you're going to lose. So that was basically when we said like, okay, we're going to stop doing any kind of classical stuff. Even on the AI side, like no SLAM, no vision pipelines, no segmentation, no nothing. This is going to be big transformers, completely end-to-end learning. Sensory information, like what you're seeing, what you're feeling goes in, lots of data, action come out. Hopefully we get some kind of emergent intelligence out of this where the robot can do something useful. Because this is infinitely scalable. The other systems aren't infinitely scalable.
Got it. So let me see if I understand this, right? And maybe this is also very useful for the audience. So with traditional robots, you got a camera on top, you got a LiDAR system. It's sort of, looking at the world. LiDAR sort of creates a 3D map of the surrounding world around it. And then you take that information into like some sort of operating system, and then you make decisions based on that, right? You say, well, the world, we're seeing this is the decision you need to make next. Now, even if you apply AI models to this, you'd apply AI models to each one of them individually. The camera is seeing something, GPT sort of, maybe you're running GPT there, the camera is looking at something, GPT vision says, well, I'm looking at a person calling me. And then you make decisions based on that. You're saying, we've thrown all of that out of the window. You're saying, we're going to do pure world ingestion. We're going to train a model on that. And then we're going to have that output sort of, we're going to teach the robot what the output is supposed to be, and it's going to learn from that. You're using a model through and through. Is that, if I'm understanding it correctly, that's what you're doing?
It's a bit important to realize that this is actually what a language model does. Because a language model operates in a very limited set of modalities, right? It sees only text. And if your AGI is basically this god in a box that only sees text coming in and outputs text, then that is like its complete world understanding. So that is a fully end-to-end model. Now, when you start adding vision, then you see this as kind of like, I like to look at it like an optical flow problem. You can think about it like the AI sees the world moving past it. It's not moving in the world because it has no way to move. It's just the world is moving past it. It's like a passive thing, right? And then when you have a physical system and you have embodiment, it's kind of like that magic moment when a baby suddenly realizes, holy shit, like I can change this. I am an agent in this world. I have agency over what actually happens when I do something. I can change the state of the world. And that's where most of our intelligence comes from. And essentially what this gives you is the ability to ground experiments. So it's like the grounding problem, like you call it in AI, which is, how do you know if what you did is actually the right thing? And I think Andrew Karpathy has a great way of explaining this, where he talks about, what if when DeepMind trained AlphaGo, instead of playing the game to the end to see the outcome when they were training it, to get like your reward, was this a good board or not? You would just present the human with two boards and say, do you think board A is better than B? And then use that to train your AI. And just basically vibe checks on boards. Now clearly this wouldn't work at all. Like we're terrible at that. So that wouldn't give you a very intelligent system. But that's actually how we train language models today. We use thousands of people sitting there and rating, is text output A better than B? And then use that to feed back into the model so you can get a training loop going. And you see this very clearly today on like most of the language models out there, that they're not clearly getting better anymore. They're kind of
capping out to human intelligence.
Yeah, or you can say they're changing, and then it depends on like how it's subjective whether it's better or not, right? It's tapping out at human intelligence. That's a good way of saying it. Now, once you have embodiment, that is no longer true, because you can now actually check your answers. You can query the world for information. You can run experiments. And my dream, of course, is that a few years from now, the robots that you have at home, whenever they don't have anything to do, they're working on whatever they're bad at.
They're doing science.
They're working on whatever they're bad at, right? It's like you. It's like, I'm not too good at this. I should probably practice a bit.
They're training.
Yeah. So much of our intelligence comes from that. And we're kind of in some way we're actually already doing this, which is very interesting. Because when the robot tries to do something and it fails and it tries again, and then after trying a few times it succeeds, there's actually a lot of information in this. And this is a very pleasant surprise to us. That like once we got to a certain scale of data on the fleet, we started seeing these emergent retry behaviors where the robot manages to get through a task it's struggling with. And we're seeing now basically a lot of the same scaling laws that you saw early in large language models. And we're seeing that the same kind of basic principles for what matters for you to get to some seemingly common sense intelligent system is very similar. Now in hindsight, this will probably be completely obvious. But in advance, it's very hard to prove that, right? So you kind of need to observe it to get the confidence that this is right. But I do think everything here goes to one model. It's not a question of whether it is a language model or like a video language, vision
It's
language.
a general world model.
Yeah, it's a general world model. And this general world model is going to be the best model to do anything from answering a question to doing your laundry.
Interesting. And let me take a crack at figuring out how you guys are training the model right now. In my opinion, I saw one video of this somewhere on Twitter where somebody was teleoperating the model. For those that don't know what teleoperation is, you sort of, at least in your case, you're putting on a VR headset, you have the controllers, you sort of control now the hands and the head of the bot. You can move the head around. I don't know if you're allowed to move the head around, but let's assume you're allowed to move the head around, allowed to move the hand around. Use inverse kinematics to predict where the elbows are and where the shoulders are. So you have appropriate movement of elbows and shoulders straight from the arms. So it's straight from the palms. And then you train it on stuff. You teach it to pick up stuff. You teach it to like, whatever you want to do, right? Like you teach it to do Lego. And then once you have enough video footage of that, I assume from what the robot is seeing, you're able to get the robot to learn a behavior. Am I completely off? Or if I'm right?
It's quite accurate. There's a few things to it. So first of all, which I think is actually quite important, is that you're allowed more creative expressionism than like what you said now. Like you can move your head, you can move your torso, you can bend down, you can lean over, you can like turn to the side. Like you can do all, so we kind of track your body, not just your hands.
Are you predicting that? Because I've done a little bit of inverse kinematics with the controllers, right? The problem is everything from the torso and beneath is random. Like in the sense you're predicting that, or do you have a camera looking at me and sort of doing pose estimation?
Actually, this is getting better and better. So to a large degree now we're switching over to more like consumer-oriented hardware because it's just more scalable and more affordable. But we do also use a decent amount of mocap, where we motion capture like in a suit to make sure we can capture your entire body. This is very important for things like how you position your feet and like all of these things when you're doing complicated tasks.
Yeah, because the Oculus won't get your feet.
Yeah, and also if you think about like how almost everything we do, especially in a home, uses your entire body. You're like leaning your knees on the cabinet door in the kitchen when you're like stretching to get that glass, right? Or you're sitting down on one knee while leaning over to reach under the couch to pick up a toy, or like you're using your entire body for these tasks. But the other part of it is actually that it's also quite important. What are you doing and why are you doing it? So I like to look at it as like you're cloning human thought and action as one process. So this would be like, I'm picking up the cups over here, I'm putting them on the cupboard so I can carry all of them at the same time to the kitchen.
So you're narrating this?
Yeah.
Do you narrate this? So I assume your video
This
footage
is narrated
looks like...
or done in post, depending on like accuracy and like how situation and everything. But yes, so language is a very, very powerful representation of knowledge, as proven out through language models, right? So the end system kind of contains all of this, right? It's video, it's tactile, it's audio. Like audio is super important for talking about a world model, right? How you know that the door in the kitchen is closed now because you heard someone closing it, right? And like so much of how you perceive the state of the world is from audio. All of these modalities come together in one model for you to solve these kind of like long-term tasks. And then same as with any kind of world model, it's basically a compression problem, right? If you have all of your experiences and you compress them enough into weights in a very small neural network, at some point it becomes more efficient for this system to learn a world model, to be able to predict what the answer to your question is, rather than remembering your answer. Kind of running out of space to store answers to every question you're answering, which might involve physical actions in this case. So you have to create a world model for this to make sense.
I have a question here. The question is, can I, hypothetically, don your VR headset and let's say your camera system or your mocap suit and start teaching it karate? I'll narrate. I'm happy to narrate why I'm doing something. And let's say I have thousands of videos made, right? I assume it's collecting information from video and the positions of whatever data format you want. And I fine tune your model, right? Or just give it context, I don't know how your model works right now, but one of the two things. would I be able to sell my karate skills for $20 a month as a subscription fee to anyone who wants to download it on their robot?
Well, so in the beginning, no. So when we launched this, it's very likely that when you talk about this kind of like, let's call it an app ecosystem, right? Even though it's more fine-tuned models, that this will be more of a creative kind of like sharing community thing. But clearly in the long term, this is potentially things to monetize.
Yeah.
The first thing that I'm working on training my droid, right? Because I have one at home, is I want it to hold the mittens to spar in kickboxing. And I want it to like give me kind of like move it fast around and like give me scores of like, what was the power and speed and all these things. And I want to compare it to my friends. It's like, here's my morning routine. How did yours go, right? Have a leaderboard. And like, there's like an infinite long tail of tasks here that people will come up with. It's just like so amazing once you have this ability to have your software do anything in the physical world, right? It's completely unlocking. We don't have a PC yet for like physical AI. There's no way to get anything done. You're stuck in a digital space. And I do really believe that's one of the big advantages of deploying these things to domestic and consumer, is that you get this enormous community of like creative people that really figures out things that you wouldn't even have dreamt of.
Yeah, and I think the App Store makes a lot of sense because it's very regionalized, right? In India, the way we cook food is probably very different from the way the West cooks food, right? So you probably have a fine-tuned model that somebody's made where they probably don't even need to understand how to fine-tune the model. They just need enough video footage or enough, let's say, raw data on positions and whatnot, right? Video positions and the position of the Oculus controllers. That is a brand new type of business. That's a brand new industry you're birthing, right? So, that's incredible. Is that why you're doing consumer robotics over like industrial robotics? I heard this one podcast between the Boston Dynamics founder and Lex Fridman, where the founder was like, I think there's no money in consumer robotics right now. And all the use cases are basically industrial or factory use cases. But you seem to be going consumer.
Yeah, no, I've known Mark for a long time, like talk about Mark Rayward, right? And I respect him a lot. He's like one of the fathers of the field. I think it's entirely correct that like there's no money in consumer robotics right now, and especially in humanoid robotics, right? But I'd also say like there's no significant money in any market right now for humanoid robotics, so we don't really know. What I would like to say is all technology kind of follows this pattern, where at first, I'm talking about very disruptive kind of technology here, where it first happens in consumer or some kind of like open market, and then it tickles up into enterprise. It's incredibly hard to come up with examples of products that are the other way around, that is very disruptive. And you could actually say this is even true for OpenAI, right? So they started with trying to sell their GPT models towards enterprise. We're doing like medium successfully. They released ChatGPT and it's everywhere. And now all businesses are using it because all of the smart, innovative, creative tech adopters around the globe, they were just like, this is so useful. I should use this as work. And now you kind of get forced adoption. But this consumer adoption curve is just something else, right? It takes you years with proof of concepts and then pilots and like rolling this out in enterprise. And we've already done with this with our previous product Eve. We have tens of Eve out there with customers and patrolling some of the most exciting, biggest buildings in space aerospace. We're doing logistics with some very big partners. All the way where we went through both the proof of concept, then the pilots, and then into commercialization. And it's a very slow process. You learn an enormous amount, so does your customer. But it's a very tough process. And consumer is very different. You get this enormous adoption curve if you get it right. And then the second and even more important part is actually the data. So I like to say that there's almost some poetry here, because intelligence comes from diversity of thought. If you think about the early large language systems. There was a lot of companies trying to make specialized large language models. They would say things like, I'm going to make the best large language model to write novels. So I'm going to curate this data set of novels that is incredibly high quality. And I'm going to train on this. And then they kind of got disrupted by the bigger models that just train on everything and then fine-tuned a bit on novels. And it just works better.
Yeah. We see this with regional languages in India. Like a lot of people fine-tune for regional languages in India, and then the next GPT is just better.
Yeah. And it's just, it is basically as simple as, if I am going to pick up a cup as a robot, how many different cups have I seen in how many different backgrounds, right? How many different weights? How slippery were they? Like all these things, right? And if you're in a factory, in a cage, moving some part from A to B every day, when you've done it 100 times, there's no more information in this. So you want to deploy into a market that is as diverse as possible. And the same general rules of AI apply. It's like the most important is diversity of data. Second most important is the quality of the data. And then the third most important is the scale. You need all three, but it's in that order. And what people sometimes fail to grasp is how complicated doing anything in the real world actually is. And you cannot really do anything useful in at least semi-unstructured environments until you have some kind of common sense, or what we would call more like emergent intelligence. You need to know how to recover when you fail and continue to like successfully complete your task. This is incredibly hard to do if you just have data from factory automation, for example. So you're essentially turning yourself into what I'd call like a self-driving car problem, where you're choosing a vertical where 99.9% success is not good enough because you're going to screw it up and hold up the line, and where diversity is close to non-existent, so you're never going to be able to get there. While if you think about consumer, and especially, for example, domestic, I mean, if we get a robot that works as well as the current Tesla full self-driving, I mean, that's incredible. You've solved the problem. And I think that's very feasible. If you want to get to this system never fails, or this system fails once a year, even, that's going to take a lot of years. But I think getting to 99.9%, that's pretty reasonable. And if my robot at home in generally has done my laundry, tidied and cleaned my house, but it like left a couple of socks on the floor and my pants in the wrong drawer, I'm still pretty happy. Like, I get to spend time with my loved ones and do the things that I love to do instead of doing these chores. And I can fix the couple of mistakes that were made. That's fine. It saved me a lot of time. So it sounds on the surface like enterprise and more structured problems is the way to approach this. And this has been true for systems that are, I shouldn't say simple, because robotics is always very hard.
Narrow.
Very narrow, right? If it's narrow enough, you can get away with a system that just repeats the motion and it's basically, it doesn't have any intelligence. Once you need intelligence, because things will be different and kind of diverse, I think the fastest and most efficient way to get to an abundance of labor is going through domestic and consumer and leveraging early tech adopters, like our fellow pioneers, right? That we really want to invite in on this journey and help us figure out how this is going to work. I mean, we're going to do our best to predict this and ship a product that is amazing. But just as when we shipped our previous product, like the first few months, we will learn so much. And we just need to be agile and fast and treat our customers really well and figure this out together.
So Neo is your consumer bot. And I think you've raised like over $100 billion at this point, right? Like over your journey. I know you can't reveal a price, right? But the curiosity is killing me, right? Like, is it going to be the hundreds of Ks? Is it going to be the tens of thousands of dollars? Is it going to be below $10,000? Or is it going to be like $1 million? What's it actually going to cost for me to get a consumer bot? And when is it going to be out? Like, do you have a ballpark date in mind?
So let me answer this simple question first. When? This is going to be a lot sooner than people think. So, I mean, humanoids taking care of the busy work so that you can really enjoy what you love to do it is very close. And I think the cost of this is kind of implicit from that. So I can't give you an exact number like you said, but it is priced in a manner that makes this feasible for consumer. So it's more in the size, like the cost range of a car. So it's not the hundreds of thousands of dollars. It's not a luxury car, it's a car. And of course, there's always a question of like, what's the model of this? Is it like a subscription? Is it a fixed up front? Is it a combination? Over how many years is this depreciated? All these things. But it's roughly in the more of like a normal good car. And it's going to come down over time. But I do think it's very important that you're able to start out at a price that is not too high, because the usefulness of this product will hopefully track an exponential, right? So in the beginning, it is very useful, and you don't want to go back to like not having a humanoid at home, right? It's your companion that helped you do everything that you don't want to do.
It doesn't matter if you lose money today, but if you win this problem statement, then you win everything.
You do, and it is incredibly exciting. I'm really, really looking forward to sharing more with the world about this and all the lessons learned and like, yeah.
Is it going to be out faster than Optimus?
I am not able to speak on behalf of Tesla, so you got to ask Elon.
So I have a question here, right? Like, let's assume, I know you can't give me specifics on, let's say, the next few months because you're building it and those dates are going to change over time, all of that. But you can play out a scenario for me 3 years from now, 5 years from now. Let's say if I asked you, 5 years from now, let's say 3 years from now, 5 years is a long time, nobody knows what's going to happen in 5 years. Let's say 3 years from now, what's it going to cost? And do you think it's going to solve everything? Like, do you think it's going to be like, what's the range of things it's going to solve? Is it going to be like playing the piano and like playing the violin and playing football with me? Or is it going to be like, hey, specific tasks, like it can do cooking or what, like range of abilities and what it's going to cost in 5 years? That's probably the question I'm asking.
Let me first take like one step back and say what I think like is, what are the key things here that you pay for, right? Because you asked the question about Optimus. And I think a different way of answering that is to say, I firmly believe that what really matters here is the safety and the affordability. So when you look at Neo, right, you can look at the specifications and you can see that this is pretty far ahead of anything else announced with respect to like weighing just 30 kilos. It can squat or deadlift 70 kilos with that low weight. It can move as fast as me. Like it can jump, it can run, it can be like do all kinds of dynamic things. Got the same degrees of freedom, got full hands, all these beautiful dynamics. But that's actually not what we're the most proud of. What we're the most proud of is that it's not an industrial machine. And that's generally where the field has been going, right? Everyone is making industrial machines. This is more like a Baymax. It's soft, it's compliant, it's got no pinch points, it's lightweight, it's inherently safe. And this is really what is going to matter for this kind of an application. So these other humanoids that you see, that are built on more like the classical way of thinking about robotics, I don't see a path where they can be deployed into this market. So we're very uniquely positioned in that sense. So when these droids will be, or other humanoids will be deployed into proof of concepts, into factories or logistics or all these things that we did a few years ago, there are some public information about at least targets for that. And I think those seem sensible. But of course, it's a very different thing to deploy into consumer. And I think the safety and the affordability is the two things that needs to be there for that to happen. And to answer your question about the like 3 years, 5 years, 10 years, basically, right? You ask a hard question. So I think the 3 years is the hardest one. it's very hard to predict where are you in 3 years. So let me start on the other end. I'm very confident that in 10 years, we have basically no more correlation between capital and labor. And society has fundamentally changed. And I think this is going to be probably the most exciting time ever in history to be alive. And I'm so glad to be part of this. And I think we have a possibility here to solve so many societal problems. And if you want to take this all the way to the limit, I'll say, for example, what are we as humanity? We're the ability to take energy and turn this into products and services that we consume. And generally, we're getting pretty good at harvesting energy. And then we're still mostly consuming calories to produce products and services. And once you break this, that's basically where we become a type 1 type civilization, right? And
Of course.
even if you think about fundamental problems today, like sustainability and climate, everything we do that is not sustainable is done because we're trying to save cost by cutting corners. If you have an actual abundance of labor, there is no more reasons to cut cost and cut corners, and you can do everything in a sustainable manner. So that's just one example, right? And there's like an infinite amount of long tail tasks there on everything from like how you can do distributed experiments in science in the physical world at scale with androids. You're no longer limited by cost of doing lab experiments, all the way to how you can start colonizing space and building out other systems. So if you go 10 years into the future, there are billions of droids out there. And I think most of them might still be humanoid, or starting to go through this shift where the market cap, basically, which it wouldn't be anymore because it's kind of disconnected, but the amount of labor being done by droids is so large that you start to get into where it makes sense to specialize again. And you've seen this now in computing, right? It started with specialized systems. Like my parallel here would be industrial robotics. Yeah. And then comes the PC. And now suddenly it's so useful, everyone starts using it. And then the market becomes so big that suddenly it makes sense to specialize again, like what is happening now. And most products throughout history go through these cycles where this happens. Like you can look at like even automotive did the same, and like all kind of like disruptive technologies go through the same cycle. So in the end, we will end up in Star Wars, right? Where we will have some agriculture drones and some mechanical repair droids, and we'll still have a very large amount of humanoids because they're generally very useful. The time in between there will be pure humanoids just because you want to get to scale. And I think if you say 5 years, I think we'd all have one at home. I think most of us might have a personal one that will help us basically do everything in life and just live a higher quality life. I think it will be pretty affordable at that point. And when I say affordable here, I think at least we have a goal of having like the limit cost of this over time, and this might take more than 5 years, but the limit cost of this after time coming down into the thousands of dollars instead of tens.
So like $4,000-$5,000?
Let's just say thousands. I mean, it's a long way out still. So, but while keeping the same or increasing the capabilities, right?
That's the cost of a mobile phone, like, or a very expensive mobile phone.
So in 3 years, I think we've had our ChatGPT moment for robotics quite a while before that. And all these droids are generally useful. They do things for you, and you see them as a companion in life that you talk to and that might know you better than anyone else. And it helps you with everything you want in life. But sometimes the illusion breaks because the system isn't perfect, and sometimes it just catastrophically fails in some manner where you're just like, oh, wait a minute. This is just data in, data out. this is not actually intelligent.
Yeah.
But it's kind of like generally giving you the illusion for such a long period of time that is going to be how it is. And then I think actually, and sorry, this is more on like the philosophical side.
No, that's fine. Feel free to take any path you want.
It's like been a big discussion in my group of friends lately. It's been like, if you think about machine sentience, right? So when we get there, and we don't know when, but like when we get there, I think one of the most interesting things that will happen is not actually machine sentience itself. It is, we will now suddenly know what sentience is. Because we don't. So like, what is this missing piece that we call sentience? And once you figure that out, you can start to backfill this in. And you can say, okay, that means mushrooms are sentient. But
in a very different way.
yeah, sure. Mushrooms are sentient, but flies aren't, or whatever, right? And then how that will affect society and how that will change the way we live once we figure out what this thing that we kind of feel is so unique to us, right? But I would say clearly intelligent animals are sentient. So what is sentience? We don't know. And I think that's going to be very, very interesting. Again, this is the exciting time to be alive, right? We're going to find answers to a lot of things. And in 1 year, which I think is maybe even more interesting, like what can you do in 1 year? I think you have a system that can very efficiently do labor through a mix of human-in-the-loop teleoperation and AI. And that you can build these systems in such a user-friendly manner that this can be done both to serve remote labor and for you to be able to train your own droid to do anything without being an AI engineer.
So it'd be a work from home sort of model for construction workers where, you know, there was this dream where, you know, a construction worker could use an Xbox controller and like control something and then not have to actually physically go and like pick things up. But here now they're doing it in VR. So paradoxically, everyone becomes a gamer, right? That's the story you're going for.
So I mean, if you know good gamers, send them our way. I mean, we've hired a lot of them lately. We have a pretty big operator team now, which is piloting these droids to teach them how to do things. It's very exciting work because one of the big wins this year is actually that the AI team isn't training the models anymore. The operators are. So we are dogfeeding this already with like making good enough UIs and good enough documentation to make sure that you can train your own models.
Is there an equivalent for a Uber style cab business here where I sort of get like a fleet of gamers, I train them and I say, here are your bots, and then they can like make their bots pretty and customize them. And I go to, you know, some construction company in India and say, you know what, my fleet will do it for you at XYZ price. They're going to do it remotely. If we prove one of those out, yeah, that's going to change everything.
It's basically the gig economy for robotics, right? It's a robot gig economy. And right now, we are doing all this ourselves because, again, like diversity, quality, quantity. It's so important for us that the data that goes into the system is high quality. So it's a pretty specialized job where you learn a lot, right? The intuition that you get when you use this system lots of hours every day teaching it how to do things is very useful. So you know exactly why something is failing and like, oh, we need some more data of this kind of task. That's why this is failing. So we're not quite there yet where I think like just anyone could do it and it will be as useful. But I mean, neither is a cab driver. A cab driver is pretty good at driving a car. That's what they do. So it might go there. It might go there.
Yeah, I'm just thinking through all the implications of this, right? Like if labor falls or becomes remote, I mean, it's like, yeah, there are n number of second order, third order implications for the economy, for the world, for jobs, for all of that. What do you think happens to jobs in a world like this? Like, what do you think happens to the economy? What do you think happens to people? How are they going to take it?
So let's walk out the example, right? So, okay, let's say that like you start in a company where this is your job. So you're doing some remote task. And hopefully you're able to do this task as efficient as if you were there. That's like the baseline. And then over time more efficiently because you have AI assistance in what you're doing through the droid. And hopefully also without putting yourself in harm's way, right? But pretty fast, you will kind of automate yourself because you're training this with so much data at this point. So what happens now, and this we already do, but what happens now is that instead you will get multiple droids, and we'll say like, okay, whenever one is struggling because it's getting to a task,
You tell you up when it's struggling.
and hopefully also it'll tell you, it'll like ping you for help, right? I failed 3 times at this task, I need help. And then at some point the human in the loop is no longer a significant cost, right? And you don't need to get to that many droids per human for that to be the case. And then after a while, the human doesn't have to be there at all. And then what you're really asking is, I think Jensen puts this really well. It is the same question as asking, what is the limit of human creativity? Because we always find things to do. And almost everything we do is not constructing houses or putting food on the table. It is in that sense kind of quotes artificial jobs that was created to increase our perceived quality of life. And I mean, there was this really, really amazing comment given the other day. I have trouble pronouncing her name, but it's like Joanna Makijewska that says like, I want AI to do my laundry and dishes so that I can do art and writing, not AI to do my art and writing so that I can do the laundry and dishes. And I think this is so true, right? That's the world I want to live in. And I don't think we will run out of things to do. I think we will always invent more things that we want to do. I don't think there is a limit to human creativity. I think we're all driven by some sense of purpose, right? Like there's such a direct correlation between purpose and happiness. And I do think and hope that this will allow a lot more of the population on our planet to do things that they feel is meaningful and that has purpose, and that will, in a very real, measurable manner, increase general quality of life.
Yeah. And as you were saying, at some point, and I'm a big believer of this, although it's not falsifiable, so I don't like publicly state it, but eventually we might find out that consciousness is just one type of a general world model, or the implication of a general world model. And then we might find out there are many different types of consciousness. And like you said, the mushroom is probably sentient in its own. I hate interchanging the word consciousness and sentience. I made that mistake here, but it is pretty interesting. Do you actually feel that? Do you feel the philosophical implication of a general world model is, something sentient popping up?
Like these philosophical arguments quickly get you into trouble, right? So
yeah, I know. That's why I don't say it.
There's this very good thought experiment here, which is called Marry the Super Scientist. Are you familiar with it?
No, I'm not.
I'll give the quick version. So Mary is a super scientist. She knows everything about light that there is to know. She knows like the wavelength, how it hits your retina, how that interacts with all of your nervous system, your brain, how you perceive this, absolutely everything. So let's just pretend she's the all-knowing God of like light and how it interacts with me as a human. So Mary lives in a box and she can only see the world through black and white monitors. And she's been there all her life. And she's studying the world through these monitors. And you can kind of like easily see here, you can make a parallel to like a box under a desk, a computer, right? Yeah. So one day you open the door and let Mary out. And now she sees colors with her own eyes. Does she learn it? And like there's written multiple books about this thought experiment. And I think the answer to that question in the end boils down to, is there anything more than just biology, right? Because by definition, if she knows everything, she didn't learn anything. So what is it to perceive something if you already have the knowledge? And you get into like a God complex problem and all these things. But the way I like to look at this is oh man, is that a hard way of figuring out how colors work? Just go out of the box. And I see this more as an engineering problem. Maybe we can get to AGI, but just like consuming tokens on the internet. But oh man, is it the hard way to go about the problem? And in a world where everyone is running out of compute and everyone is running out of data, if you have better sample efficiency and relevancy in your data, and you need less compute because sample efficiency and relevance of your data is better, you're probably in a very good position.
Yeah, you just have to give it feet and hands, and then it'll find things that don't exist on the internet. Interesting. I have two more questions for you. I want to deviate from this path for a while. Have you heard of the Unitary G1? It's so we were looking for a bot that we could experiment with, right? Ideally, this is the old way of doing things, I assume, now that I've had this conversation with you. So the way is, G1 has a robot operating system sort of SDK like package, and we thought we'd get it, we'll play around with it. We played with, so there's another company called Yaboom which has this quad robot, right, like the dog, and we have one of those in the office, and we were playing with it. We've gotten to the point now where we can, we don't need to play at they have two levels of abstraction, right? One is on the level where it's like there are pre-programmed commands to move from point A to point B, and the other is where you can directly manipulate the joints. And we've gotten to the point where we can now directly manipulate the joints. So we're learning a lot more about it as quickly as we can. And we wanted to play with the G1 because it's a bipedal robot. But when we actually spoke to them about pricing, the advertised price is $16,000, but the actual one that you can program is about $35,000, roughly around that much. So a lot beyond our budget range. But are you worried about China? Is it eventually? So there's two kinds of ways, right? Like there's the Apple model where you build the entire thing and you build the software, and then maybe the Android model where I just get this bot, I put a skin on top of it, maybe a human-like skin or like a furry skin or something like that. And there are a bunch of companies in India that have done this very well. They get Chinese manufacturers to make the headphones or like the earphones, and then they put a sticker on top of it, they brand it really well, and they build a company around it. What route do you think most people are going to take?
Yeah, so let me answer on the Unitary one first. So first of all, I think it's quite important to point out that what Unitary is doing is actually very good. They don't follow the classical kind of sense on the hardware side. They don't have the 10 mechanisms and things that we do, but they do have pretty low gear ratios. So you can see like the dynamics of their system is pretty good. Like it can walk and run and do these things a lot more natural than most other humanoids. So I think they built a great product, and I think it's gonna be very disruptive in the academic scene, in the sense of enabling a lot of academic labs to start researching AI without having to build the hardware. That being said, the system is mostly built for legged locomotion with some manipulation, and it's quite limited in like the dexterity that it has to do fine manipulation. Mostly a combination of like how the actuators are and also the number of degrees of freedom. But I think they're way ahead of anyone else currently with a commercial product when it comes to price. I'm not worried about this generation. Like I feel the system we built is very capable. It is very affordable, and we're able to compete very well here. I do think over time there will be two paths here. It is China builds the hardware and then we build something on top. Yeah. Or like you said, the Apple approach. Now, clearly I have very much conviction on the Apple approach being the right one here, given that we do everything from copper in, aluminum in to robots with intelligence out. And the rationale for that is that this is actually not a disconnected problem. Like so much of your intelligence lies in the way you move. And our ability to go all the way down through the stack to change things to make our system work better that is how we keep ahead in the AI game. And this goes for like the dynamics of the system, like how does your system respond when it's opening a door? or even like your camera system, right? And like how do you tune this for the AI to work well? And there are so many things that comes into building this complete end-to-end product that enables you to do this. And also manufacturing is such an important piece of this. And even for cars, right? You see that it's not the pure software layer that wins. It is actually the vertically integrated. And the most successful companies are the car companies who manage to actually do a great job with software and AI, even though they build the manufacturing and car itself, which is very hard from like an executional point of view. And robotics is the same, but more complicated. So if you think about Apple, which interestingly actually does outsource their manufacturing. This works because a phone is quite complicated, but it's not that complicated from a manufacturing point of view. But now when Apple tried to, for example, do this with a car, it didn't go so well. Because you cannot disconnect the design process from the manufacturing process with a car. It is so inherently coupled. You have to start with the manufacturing and then figure out how do I design a car that I can manufacture. Robotics is no different. And traditionally here, China has been very strong. I do think it's very, very important that we build companies here who are vertically integrated all the way from the manufacturing and all the way up to the AI. Because that is how you can combine the best of these two worlds. And this is what is going to get you to, in the lack of a better word, get us as quickly as possible to a system similar to something we would call AGI. But it's very easy to underestimate before you worked a few years in the field how much the dynamics of the system and how you design your system actually matters to how well your AI behaves and what your system is able to learn. And another way to look at it is, can you just take any amount of data and use it to teach any system how to do something?
Yeah.
And to me, that comes back to an engineering problem. Like you can solve cross embodiment and say like, okay, we explored the world as a car and as a dog, robot dog, and now we're going to use that to figure out how to move around as a humanoid. Might work, but it's going to take a lot longer of time. And it's going to require a lot more data. And it's just generally going to be less efficient. And it's a problem we don't need to solve.
Yeah, the true general world model would be you're able to put this in anything that has electricity and the ability to move its joints. It could even be human transfers. Like I've had a brain in my hand.
That's an assumption. I'm not sure I agree on that, because again, your body matters so much to your intelligence. So even animals, right?
Would it be adaptive?
But like even animals learn how to move. You're not born with the ability on how to move. You learn it because it's so tuned to your specific body. And I think it might not also necessarily be true that intelligence always would only live in kind of like the cloud, more like a hive mind. A lot of intelligence will live at the edge. And I think in general, this question does not come from what I would call like the most sensible basis. So it's more a question of like, as a typical VC or investor, can you keep only investing in software? Because you would like to be the one that creates leverage, not the one that creates what can be leveraged. But if you don't invest in what can be leveraged, at some point you will have nothing that you can leverage, and it doesn't matter how much you invest in things that can leverage.
Is that because of commoditization or of software, or is that because the hardware is so tightly coupled with the software at this problem statement?
It's both. So from the investment point of view, it's generally that software has been proven to be very, very scalable and therefore a good investment. So you kind of have a well-established investment thesis for how to invest in software. And generally you've avoided hardware because hardware, it's generally a bit bad investments. But if you look at the biggest companies in the world, they're all vertically integrated hardware plus software companies. And there's a reason for this, right? It is the most efficient way to go about the problem. So from a company and engineering point of view, I think it's pretty obvious that like we want to control the manufacturing and the droids. We want to make sure that we have the full ecosystem. We want to have the data. We want to have the fleet. We want to have all these things because that's what puts us in a unique position
You build
to
an
build the most
ecosystem.
intelligent system. And there will be competitors that will be having other strategies that might be more fragmented, but also might be interesting approaches to this. I don't think it's a winner takes all. I do think it's a winner takes a lot in the beginning. It's very hard to catch up to someone who has a very large fleet size, therefore a lot of unique data, and therefore can basically just provide services and capabilities that your competitors can't, and also operate at the manufacturing costs that your competitors can't. But the market cap here is so big that there will be multiple strategies, and that will ultimately that will give consumers the ability to choose, right?
That's interesting. I actually, there was one point in there that, maybe I didn't get enough clarity on. I had this was like, I think a dinner I had like a few weeks ago where we were thinking about, well, if there is a general world model, right? And it would be perfect at input output. Have you seen Spider-Man? You've seen Spider-Man, right? There's this villain in Spider-Man called Venom. And Venom is basically a symbiote. It's like this alien organism that can sort of work with any input output. Like it can blend with you in a way, like it can it's a symbiote. So it sort of merges with you. And then if you've got eyes, it's able to use the eyes. If you've got arms, it's able to use the arms. Technically in the comics, it can even take a plank of wood, sort of integrate with it and see, is there a way I can move this thing? Do you feel, and that's why I asked the question of, is it software through and through? And is the hardware not very important over a 20, 50 year horizon? Is it just this intelligent piece of software that you can just throw at any animated object with joints and maybe electricity and it can just make it move?
The honest answer is I don't know. But I do think it's interesting to think about, try to strongman the other side of this argument. So what if it's actually all at the edge? That's kind of how we work, right? So all of the intelligence lives in each individual droid, and the communication between them is kind of like the mesh network that exchanges information and gives your intelligence robustness. It's kind of like a distributed system, right? Centralized decision making is not always the best. I would say actually very seldom it is. And like an analogy here would be, think about capitalism. So ultimately what capital is information, like local pricing, for example, regulating production. So you can think about capitalism as a distributed computing system that computes your resources for you and what you produce. I think it's very likely that intelligence is the same. And it lives at the edge. And it's pretty unique to you and your unique local input. And how you are tuned to this local input, because this is where you've spent your time. And how this kind of like different experiences that we all are part of out through life gives us unique perspectives, and these unique perspectives is what makes the total a good decision maker.
So you're saying if I was born without eyes, I'd have a very different consciousness. I'd have a very different experience of the world. I mean, I would have a very different experience of the world, but my intelligence would be different.
Yes, I think so. It would be very different. In that you would value different things. So whether or not we call that like a different intelligence, that's I think more of like a terminology question. But clearly, if you speak to someone who has been blind all their lives, they think about life in a different way. I mean, they have a unique perspective. This is why again, right? It comes back to diversity. Diversity of thought, diversity of body, diversity of experience, diversity of tasks. This is where your intelligence comes from. And I'm not so sure that everything will always be centralized in like one big giant model living in the cloud, kind of like a hive mind, making all the decisions. I think the system might be inverted. This is of course speculation, but that's how nature works.
Interesting. I have just one last question for you, and this is probably a question you've been asked multiple times, right? Is there a Skynet scenario that's ever going to play out with this? Are we going to see Terminator? Sorry, I just had to.
No, it's actually a very, very good question. So, but when most people think about AI risk, right, it is the Terminator case. I do think the real risks with AI is just like any tool. If you don't use it correctly, it can basically create a leverage for you as a bad actor to do more bad things. And I don't think the likely outcome here is a Terminator. It's just very, very rare to find, for example, science fiction about the good case. We're always like drawn to the dystopian story, right? Because like that's, and so am I. It's like it's engaging. It creates like these deep, unique characters went through all this suffering, and like we win versus this external enemy of like the sentient whatever kind of AI that went rogue in this kind of universe. But actually, I think in general, the more intelligent the system is, the more it values life, the more it values diversity and realizes how important diversity is, right? So if you think about humans kind of like a bag of information, the more kind of like intelligent we are, the more information we contain. And this is precious. So I don't see why intelligent systems that are more intelligent than us should not respect life. That being put aside, I think this is an alignment problem. And I think we're pretty good at that. It's something that's being extensively studied and something that's very important. And something also that we're working on with respect to, for example, robot safety models and how to ensure, for example, that you don't, by accident, do something bad. And this is a deceptively hard problem because you need such an understanding of the context of your tasks to be able to make the right decisions. So if you think about us, right, whenever we do anything, we're doing these forward simulations of like what could go wrong. It just happens naturally for us, right? I'm picking up the coffee cup and I'm like, if there was a kid right next to me, I would be aware of the risk with respect to this. So these kind of like micro safety assessments that we do all the time, they're basically forward simulations in a world model. And that is what you need, right? That is how you ensure safe behavior, is that when you're searching through your world model for whatever answer or policy that you're going to carry out to do the task, you ensure that this path is pretty far away from tasks that might have unwanted behaviors. And I do think that's a very important and hard problem, but a solvable problem. And then I'm not too worried about just basically sentient AIs going rogue. I think this is mostly a science fiction thing, and I'd actually recommend people read some less dystopian science fiction where these things go well and see how we can build a society which is just so rich by coexisting with these things that we can leverage and can help us live a better life.
Interesting. This has been an exceptional conversation. Like, I've learned so much. I have a much clearer picture, I guess, of the future because, you've just been in the space. You know what everyone else is up to. Your timeline seems short. It's not like this is 20 years away, 50 years away. And I'm glad we have consumer robotics around the corner. Dad promised that he'd send me one. And, one of the things I want to be one of the first people in India to have a 1X bot, right? I think that would be nice. Thank you so much for doing this. I don't know. It's just, this has been a really good conversation, and I hope you felt the same.
No, I really enjoyed it, and I'll make sure you get one of the first ones, and I'd love to invite you in on the journey, right? It's smart, experimental people like you that we really need to figure this out, because it's a completely new space, and it's going to take a lot of community to get it right.
Yeah, I'm going to teach you some karate. I'm also going to teach you to use the cameras. We're going to make it do fun stuff. And hopefully I'll be, if you ever make a marketplace, we'd love to fine tune these models and make some money out of it.
Sounds great.
Awesome. Thanks so much. Bye.